angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. So, first let us draw a figure based on this information. So, in the question it is given there is a tower. Let us consider this AB is the tower. Then it is given the angle of elevation of top of the tower is 30 degree. Angle of elevation. It is formed when a person is looking up. So here is forming an angle of elevation 30 degree that we have marked here. Then from which point that person is looking up to the top of the tower? That point is 30 meter away from the foot of the tower. Here the foot of the tower is B. So 30 meter away from the foot of the tower it is C. So from this point C, a person is looking to the top of the tower and there is forming an angle 30 degree. So this is the figure. We need to find out the height of the tower. That means we need to find out AB. So for this acute angle C, this AB is the opposite side. The given side is BC, it is the adjacent side. Let us take the ratio. We have tan theta equal to opposite side by adjacent side. Here theta equal to 30 degree. Tan 30 degree equal to AB by BC. Tan 30 degree is 1 by root 3. 1 by root 3 equal to AB by 30. The measurement of BC is given in the question. It is 30. So, let us cross multiply. We get 30 equal to AB into root 3. Let us change the sides. We get AB into root 3 equal to 30. AB equal to 30 divided by root 3. That is equal to 30 by root 3 into root 3 by root 3. Why we are multiplying here with root 3 by root 3? To make the denominator a rational number. So we get that is equal to 30 root 3 divided by 3. This 30 and 3 we can cancel. We get that is equal to 10 root 3. So let us conclude. Therefore, height of the tower is 10 root 3 meter. Kite is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string assuming that there is no slack in the string. So there is a kite at a height of 60 meter above the ground. The string of that kite is tied to a point on the ground and that string is making an angle of 60 degree with the ground. The string is tied tightly. We need to find out the length of the string. So, let us draw a figure in this case. So, our kite is here and this is the string. It is tied to a point on the ground and it is making an angle of 60 degree with the ground. And again given The kite is at a height of 60 meter above the ground. So this height AB is 60 meter and this angle is given 60 degree. We need to find out the length of the string. Here the acute angle is angle C with measurement 60 degree. For this acute angle C, this AB is the opposite side and AC is the hypotenuse. Opposite side is given. We need to find out the hypotenuse. So we have to take the ratio of opposite side and hypotenuse. We have sin theta equal to opposite side by hypotenuse. Here theta equal to 60 degree. So sin 60 degree equal to AB by AC. Sin 60 degree we know it is root 3 by 2. AB is given in the question, it is 60 meter. So we can write root 3 by 2 equal to 60 by AC. Let us cross multiply. We get root 3 into AC equal to 2 into 60. That is root 3 into AC equal to 120. AC equal to 120 by root 3. Now you see the denominator. It is an irrational number. Let us rationalize it by multiplying with the root 3 by root 3. So that is equal to 120 by root 3 into root 3 by root 3. Root 3 into root 3 is 3. So we get that is equal to 120 root 3 by 3. Now let us cancel this 120 and 3. We get that is equal to 40 root 3. So we can conclude length of the string is 40 root 3 meter. 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. So first let us draw the figure based on this information. So there is a building. A boy with a height of 1.5 meter is standing here. Here the height is mentioned specifically. So we need to mark that height here 1.5 meter. He is standing here and looking the top of the building. So this is the horizontal line and this is the line of sight. So the angle of elevation is 30 degree. So here the angle formed is 30 degree. Then the boy is walking towards the building, walking near to the building. The boy is walking towards the building. As he walks towards the building, this angle of elevation is increasing. It is increases from 30 degree to 60 degree. So here we can mark the angle of elevation once again. In the second case, angle of elevation changed to 60 degree. So once again I will explain. This is our building. A boy is here with height 1.5 meter. From this point, he is looking to the top of the building at an angle of elevation of 30 degree. Then the boy is walking towards the building. When he reached here, he again looked to the top of the building. Now the angle of elevation changed. In this point, the angle of elevation was 30 degree. But in this point, the angle of elevation is 60 degree. We need to find out the distance he walked towards the building. How much distance he walked. First, let us give the name for that triangles. So here I have given A, here B, here C, here D, here E. Now this AC is the building. We know the height of the building is 30 meter. Here you can see two right triangles, A, B, D. First one. Second one is A, B, E. I am going to draw it separately. So the first right triangle is A, B, T with the angle of elevation 60 degree. Second right triangle is this bigger one, ABE. ABE with the angle of elevation 30 degree. So in both case, we need only the length of AB. Here, length of AC is given 30 meter. How can we find out this AB? Here you can see this 1.5 meter is the height of the boy. So this BC will be 1.5. So this AC is 30 meter. BC is 1.5 meter. Therefore this AB is 30 minus 1.5. That is 28.5 meter. So I have marked here AB is 28.5. Here also I have marked AB is 28.5. Now you consider the first triangle. Here the acute angle is angle D with measurement 60 degree. For this acute angle D with measurement 60 degree, this AB is the opposite side and this BD is the adjacent side. So let us take the ratio in this triangle. In triangle ABD, tan theta equal to opposite side by adjacent side. Here theta is 60 degree. So tan 60 degree equal to AB by BD. Tan 60 degree is root 3. AB is 28.5. So root 3 equal to 28.5 divided by BD. Cross multiply. We get BD into root 3 equal to 28.5. Take this root 3 to right side. We get BD equal to 28.5 divided by root 3. Now you consider the second triangle. Here the acute angle is angle E with measurement 30 degree. For this acute angle E, AB is opposite side and EB is adjacent side. There also we can take the ratio. In triangle ABE, tan theta equal to opposite side by adjacent side. Here theta is 30 degree. Tan 30 degree equal to AB by BE. AB is with measurement 28.5. So 1 by root 3 equal to 28.5 by BE. Tan 30 degree is 1 by root 3. Cross multiply, we get BE equal to 28.5 into root 3. Now you see the figure. What is this BE? BE is this total length. BE equal to BD plus DE. So we can write BE equal to BD plus DE. So here BE we can replace as BD plus TE. So we get BD plus DE equal to 28.5 into root 3. Now we know what is the value of this BD. Here we have written BD equal to 28.5 by root 3. Let us write it here. So we get 28.5 by root 3 plus DE equal to 28.5 into root 3. Now this 28.5 by root 3 we can move to right side. Now we get DE equal to 28.5 into root 3 minus 28.5 by root 3. Now to do this calculation, let us cross multiply it. We get DE equal to 28.5 into root 3 into root 3 minus 28.5 whole divided by root 3. This is 28.5 into root 3. Then this root 3 also multiplying to here minus 28.5 whole divided by root 3. Now we know root 3 into root 3 equal to 3. So we get 28.5 into 3 minus 28.5 whole divided by root 3. That is equal to 85.5 minus 28.5 whole divided by root 3. That is equal to 57 by root 3. Now you can see the denominator is an irrational number. Let us rationalize it. That is equal to 57 by root 3 into root 3 by root 3. That is equal to 57 root 3 by 3. 57 and 3 we can cancel. We get that is equal to 19 root 3. So this DE, this length is 19 root 3. The question is how much he walked towards the building. So this ED is the distance covered by him towards the building. So let us conclude. He walked 19 root 3 meter towards the building. A point on the ground, the angles of elevation of the bottom and top of a transmission tower fixed at the top of a 20-meter high building are 45 degree and 60 degree respectively. Find the height of the tower. So let us draw a figure first based on this information. So there is a building with a height 20 meter and a tower is fixed on that building. Then it is given in the question from a point on the ground, the angles of elevation of bottom and top of the tower is 45 degree and 60 degree. So this is our ground. A person is standing at a point on the ground and he is looking to the bottom and top of the tower. This point is the bottom of the tower. This point is the top of the tower. The person is looking to the bottom and the person is looking to the top. Looking to the bottom at the angle of elevation 45 degree. Let us draw it. So from this point the person is looking to the bottom of the tower at an angle of elevation of 45 degree. Then from the same point he is looking to the top of the tower at an angle of 60 degree. So from the same point he is looking to the top of the tower at an angle of 60 degree. Always you remember, you mark this complete angle is 60 degree. Don't limit it till this first line of sight. This one is first line of sight. This one is second line of sight. This is our horizontal line. You should draw the angle till the horizontal line. Now let us give a name for each points. So I marked here A, B, C, D. This BC is the building. It has height 20 meter. Now let us draw the right triangles separately. First right triangle is triangle BCD with acute angle 45 degree. Second right triangle is triangle ACD with acute angle 60 degree. Question is to find the height of the tower. Which is the height of the tower? It is AB. So we need to find the value of AB. Let us solve the problem. You see the first right triangle with the acute angle D with measurement 45 degree. For this acute angle D, BC is the opposite side and DC is the adjacent side. Let us take the ratio. In triangle BCD, tan theta equal to opposite side by adjacent side. Here theta equal to 45 degree. Opposite side is BC. Adjacent side is DC. So we can write tan 45 degree equal to BC by DC. We know tan 45 degree equal to 1. BC is 20. So we can write 1 equal to 20 by DC. Cross multiply it, we get DC equal to 20. So we got the value of DC, it is 20. Now consider the second right triangle with the acute angle D with measurement 60 degree. For this acute angle D, AC is the opposite side and DC is the adjacent side. Now we proved DC equal to 20. So we know the adjacent side. We can find out opposite side. So let us take the ratio. In triangle ACD, tan theta equal to opposite side by adjacent side. Here theta equal to 60 degree. Opposite side is AC, adjacent side is DC. So tan 60 degree equal to AC by DC. We know tan 60 degree is root 3. So we can write root 3 equal to AC by 20. Cross multiplying, we get AC equal to 20 root 3. Now you see the figure. What is this AC? AC is AB plus BC. AC equal to AB plus BC. So here we can replace AC by AB plus BC. That is AB plus BC equal to 20 root 3. We know BC equal to 20. So AB plus 20 equal to 20 root 3. AB equal to 20 root 3 minus 20. Now you can see this is 20 root 3. This is 20. From these both numbers we can take 20 outside. So we get 20 into root 3 minus 1. If we take 20 outside from this number, there is remaining root 3. If we take 20 from this number, there is remaining minus 1. So we can conclude, therefore, height of the tower is 20 into root 3 minus 1 meter.